The day we synchronized number 7 was, it was a roller coaster.
That is the most significant milestone on the power plant project.
If you would have asked anyone who was there at the time to really picture what would have been going on at the end of the project, it would have been difficult to describe.
It was like a breath of fresh air. Like we have done it, we have achieved, we have made the nation proud.
The exhilaration that goes through your mind, you even forget that there was a time that you were under stress because the euphoria that filled this control room was just too much.
The joy cannot be expressed. Yes, congratulations.
Project is the biggest high-value project Zimbabwe has undertaken since independence. The first step was to start with the geotechnical and topographical surveys, which we did as initial activities prior to the actual commencement. Then 2018 August, when the contractor fully mobilized on site, they moved in with a lot of these people, know them as yellow machines, to start excavations. You first started site leveling, and then you start the excavations for the foundations of the various structures on the project.
The designs would come in from the Chinese contractor. So we would review those designs to see if they are in line with our contractual requirements, which we call the employer's requirements, if they are in line with the standards that we use at this project. Our contract dictates that we should use the best international standards that they are.
And once we had completed the designs, we went to the phase for the manufacturing. And during the manufacturing, we also had several inspections.
We actually managed to see one of the factories where they manufacture the boilers and the turbines. These are FATs which are done. Why is this done? You want to ensure when something comes to Zimbabwe, it's exactly what you have asked for.
If you had come here early 2019, the ground was plain. It was just holes and pockets for foundations. Our role as the civil engineering department is to provide the support infrastructure that will enable the plant to be functional.
2019 in February, March, that's when we poured our first concrete onto the structure for the foundations of the power plant.
All the infrastructure that you've seen, the roads, the dams, the buildings, we provide the infrastructure on which the power plant, the mechanical and electrical components are supposed to be sitting and functioning from. One of the interesting structures was the cooling tower. Ours is the largest natural draft cooling tower in Southern Africa. Because of its nature, it's not a structure that you come by on a daily basis. It's been particularly interesting because, number one, it was on our critical path, and we had to do it in record time. The way we were doing the cooling tower was in such a manner that at any given time we were pouring about 240 cubic meters of concrete in a day. We would pour a layer today. The next day we are doing reinforcement for the next layer. The next day we are doing formwork. And then the next day we are actually casting concrete. Immediately after that, we are actually now going to the next layer. So our formwork was it was done in 3 layers. So at any given time, we will be housing or we will be forming concrete for the past 2 days. And the next day, we're actually taking it to the next level.
Currently, we are installing the precast concrete columns and beams, which are responsible for carrying the cooling water distribution pipes. We are also working on the anti-corrosion of the cooling tower. This is a 6-layer anti-corrosion paint which is being applied inside the cooling tower. We are also working on the ponds floor slab, reinforcement as well as concrete pouring.
By the way, the dimensions were 120 meters diameter at the base and 150 meters height. From foundation to 150 meters, I think it took us about 5 months. At this stage, we have done over 200 structures. That's probably over 20,000 square meters of ground floor area. Now going up, the figure easily goes to 100,000.
Getting that equipment on site.
We had now to inspect it to see, is it the equipment that we witnessed in China? Is it the same equipment? And then we also had to trace to check if the material is still the same. And then we'd do some third-party tests. If we have any doubts, we'd test at SAZ, also at UZ, third parties, just to verify.
Event, and it was at a grand scale. It meant being innovative in ways that we had never seen before.
At the height of the COVID-19 pandemic, you would find that almost all the equipment, some manufacturers would close down the shops, we could not get raw materials to the factories, we could not get ships.
Of safety, we were looking at people who were going to do the work. We were also looking at the procedure. This is where the preparation was done. We looked at the method statements to ensure that the way that they're going to lift was correct. People who were working were wearing safety harnesses which were anchored on lifelines. And we also had people who were wearing red. Those were the safety personnel, and they'll direct people which ones are the safe zones, which ones are the red zones. We're also using our barricades, and communication was very key for everyone to be safe and for the equipment to be safe.
So as control and instrumentation, our major role was to complement the mechanical engineers by putting the control logic behind the lifting operations that are to be done here. We have a separate control system for the crane for Unit 7 and for Unit 8, and one control system was the master, basically meaning that it will be controlling every operation that will be done, and both cranes, they were coupled together through some communication cables and doing the same thing at once.
The generators at Hwange expansion project, that is for Unit 7 and 8, they are rated at 335 megawatts, and the generating voltage is 20 kV. At the stator terminal assembly, that's where we can now evacuate or transmit the generated power that is via the isolated phase buses to our generator step-up transformers, which are rated at 400 MVA, and the step-up voltage there is 20 kV, which is being stepped up to 400 kV.
And we are also witnessing another very important milestone in terms of the unit number 8, where we are also lifting into position the boiler steam drum for unit number 8. This is a very delicate operation.
The drum is going to be lifted to an elevation above 60 meters. This drum that will be lifting, it's of 161.3 tons, which is massive. Hence, the lifting equipment that we are going to deal with has to have enough or adequate safety factor so that we don't encounter failures of wire ropes during the lifting.
Now, the boiler is a critical component of the power plant because it is the component that generates steam. So this steam will then later be used to turn the turbine and in turn the electric generator that will produce electricity to the, for transmission to the grid. So the boiler at Hwange Expansion Project is a 335 megawatt subcritical boiler with an output, a rated steam output of 1,110 tons per hour at boiler mean continuous rating. The height of the roof is at 75.4 meters and our rated steam output is a temperature of 541 degrees Celsius and a pressure of 17.4 megapascals.
On the milling plant side, we have received 6 ball mill shells, 3 for boiler 7 and 3 for boiler 8. And for boiler 7, we have already installed the shells into place using a combination of winches and pulley blocks. So we also have classifiers that we have received on site, 3 for each unit, and we are yet to install them. And on the main boiler side, the drum is in place, and now we are working on adjusting the downcomer pipes so that they are aligned in preparation for the welding works.
The turbine is the one which is in between the processes.
So currently we are on the 12.6 meter floor, the operating floor. So the Unit 7 turbine, we have the alignment of the LP lower outer casing with the saw plates. This is the preliminary alignment before we move on to the final alignment.
The turbine is so delicate. We actually measure clearances in micrometers. So you'd actually use what we call a feeler gauge. Miss any of that, and the moving parts and the non-moving parts will rub, and you have huge vibrations.
The power generation process. Thermal and hydropower generation processes are the main source of electricity in Zimbabwe. In thermal power plants like Hwange Power Station, coal is the main source of fuel. A huge amount of water is required for the generation process. The water is stored in a reservoir and demineralized to remove impurities in the water treatment plant, then fed into the boiler for heating. Coal is burnt in the boiler firing chambers. The boiler heats the water into high pressure and temperature steam that is fed into the turbine. The main function of the turbine is to convert the heat energy in the steam into mechanical rotation. This happens when the steam strikes the turbine blades, which in turn rotate and convert heat energy into mechanical energy. The turbine is coupled to the generator such that one revolution of the turbine is one revolution in the generator. The steam exits the turbines into the condenser, where it is cooled into liquid form using the cooling towers. The mechanical energy is converted into electrical energy as the generator rotates. Electricity is stepped up and transmitted to substations.
For this power plant, our balance of plant consists of the water system, the chemical system, the ash handling system, the coal handling system, the compressed air system, and the heating, ventilation, and air conditioning. So we have got a coal handling plant, which houses or which carries all the coal that needs. And then from the conveyor belts, we feed it into the bunkers, and the bunkers feed into the boilers. And then the coal is ignited and it's burnt in the boilers. From the inputs, for the boiler, we need water. That's the water which is heated in the boiler tubes.
So in the case of Hwange Expansion Project, the water is being drawn from Zambezi River. There is a pumping station there, we call it the Deka pumping station. It is on the mouth of the Deka River, so we call it the Deka pumping station. And that pumping station pumps water all the way from Zambezi River to Hwange Power Station, I think more than 42 kilometers.
So this project is going to provide the reliable supply of water as an input to the generation of electricity on the Hwange expansion project. What we are seeing here is the first phase of laying of pipes. In general, the total cost of the project is about 48.1 million. It consists of these pipes that we are seeing, which are 960 millimeter in diameter. And it also covers the upgradation of the existing pumping station in Zambezi, where we are putting some spare pumps and also some spares for the existing pumps. We are also putting SCADA systems to improve the operation and maintenance efficiencies of the pumping station. The scope also covers upgradation of the Zinwa pumping station, where we are also planning to augment the water supply to the Hwange community. We have decided to provide tapping waters for the community, 3 tapping points, where it is going to provide water for irrigation and also supply water for livelihoods that caters the schools and the clinics along its way from Zambezi to Hwange Township.
Now, when you have got the water, you need to make sure that the water is as clean as possible. So there are various processes that the water has to undergo before it is used to produce steam. So from the raw water reservoirs, the water will flow naturally by gravity to a water treatment facility. At the water treatment facility, the water is purified to a state which is cleaner than the water that is safe for humans to drink.
Our daily water demand for the Unit 7 and 8 is 1,860 cubic meters per hour. This includes all the water that is needed in the plant. The reason why we need to treat water, our boiler has got our specific water parameters, such as the specific level of turbidity, conductivity, and hardness.
Then after you finish the installation of the various equipment and the joining, the next phase will be to test the individual subsystems. We call that the commissioning process.
The power station is interlinked, all of the equipment is interlinked. But before you run any piece of equipment, you have to make sure that on its own it is running in the proper way. Otherwise, if you don't do that, it has a knock-on effect on the other equipment.
Commissioning is a systematic approach, which is the transition between construction and the operations or commercial operations of a plant. So what we'll be doing is we'll be starting up, testing, starting up plant and checking for functionality, checking for safety. So this is basically, in a nutshell, what commissioning is all about. So the final thing that we do then, we do what we call performance testing. Performance testing is whereby we actually have to ascertain the difference or the similarities between the specified parameters and the actual parameters.
So the hot commissioning officially would lead to the final step, which is the important step on the project, which is the synchronization. You are now ready to connect the power plant for the first time to the national grid. And a lot of emotions will be running through, and a lot of thoughts will be running through your mind. Is it going to be possible? Can things go wrong? Will it be a smooth process, and so forth?
We were pressed for time as well, even the time within which to do it. So there were a lot of things that had to be tied together, and the running around was just too much. It was running too much. You sometimes think you'll break down because of fatigue.
The nation was expectant, and everyone wanted to see, is this machine going to really work? And including ourselves, the ones who had been implementing the project, we were so anxious. So everyone was there in the control room, waiting, very anxious, and the operators were doing their jobs We gave them the space, but there was a lot of anxiety. Will things go right?
We have closed the 20 kV isolator, which means the next closing of the breaker that we are going to carry out is the live synchronization of the machine to the system, and then being able to push megawatts into the system.
汽轮机转速3000转，检查7号机汽轮机转速3000转，汽轮机3000转，已正常。
There we closed the breaker and there we were, 26 megawatts immediately after closing the breaker. The whole control building erupted. And it was a joyous moment for all of us.
So it has been a great achievement for us. All the sleepless nights and all the heavy loads, the workloads that we had, they paid off at the end of the day.
The fruits of the hard work had finally been realized, and people were so glad. And we started ramping up the machine, and we're happy it was very stable and was capable of producing the power as it was designed, intended to do. Then we have got new substations. One is the Hwange B substation, which is essentially a 400 330 kV substation, which means you can either step down to 330 or step up to 400 depending on what you want to do with the power. You want to transmit it via 400 or via 330. It's important to ensure that the power that is generated reaches the least, or rather the consumers in the most remotest part of the country. So for this project, we have got an additional transmission line to the already existing 3 transmission lines at Hwange to make it a total of 368 kilometers.
What you are witnessing here is the tower erection of G-Type 1 towers by Sino-Hydro and ZPC site monitoring team. Before we start erecting our towers, we first begin by conducting a safety talk, followed by a pre-risk assessment. We then follow through by inspecting all our equipment to ascertain that they comply with the highest safety standards specified in line with this type of work. The actual tower erection is done in 3 simple steps. We lift the crane. We use the crane to lift one leg and support it with temporary stays. We do the same thing to the second leg. Finally, we connect the 2 legs by the cross arm and support the entire tower with permanent stay wires. During the entire process, we continuously check for horizontal and vertical alignment using our trusted tool, the Total Station.
Our stringing involves 3 wires, as per se. It involves the fiber, the optic fiber for communication. It also involves the GSW, that is the galvanized steel wire for earthing purposes, then the conductor itself. After the stringing comes the tensioning, that is the sagging and tensioning of the conductor, putting it at the right level. From there then, that's when we go on to installation of spacers. We have a team after the spacers. We have a team that comes again on the towers putting fittings.
So for a transmission line, you need a straight corridor that provides a convenient path for transmission of power. So when we do the topographical survey and cite the route to be followed by the line, obviously we do so cognizant of the fact that at some point we will meet obstacles. Some will be households, some will be trees, who can clear those.
This brings us to the RAP project, which is basically the relocation allocation plan, where we need to move the homesteads out of the wayleaf to pave way for the construction of the power line. A relocation action plan basically is a plan to make sure that the project affected people, we call them PAPs, are actually compensated. So currently what we have is affected homesteads are basically 88. But the homesteads which we need to build are around 80 homesteads. We are building state-of-the-art homesteads, and we are also bringing things like water to them. So to the communities, to me, it's actually a welcome development.
Sifike lapha ePing Forest ngo-2011. Sihlala ngale ngaphezulu okwabuya khona ilayini yamagesi. So wami umuzi waba ngumuzi wokuqala uku-affectwa i-pylon lamagesi ngoba lahle labuya direct lafaka i-balancer phakathi komuzi.
I-pylon yathi sakhiwa yanthola ngikhona apha i-pylon yokuqala ivele ngihleli khona la kwazobuya li-pylon yesi-2 bafika apha bangikhuluma lami ukuthi bafuna ukuthi bengisuse lapha i-pylon ihambe ekhaya angisolanga ngavuma apha le ize siyokuqala yahamba la azange ngikhathaze ngoba engadlula ekhaya lami ngangihlezi eceleni kwakhe ize salesi-2 isiquma phakathi kekhaya yazoquma futhi phakathi komuzi zakulesihlahla soyenjeleli emtolo wabantwana lapho ubaba ezenzela khona amacala konke into ekumele kusuku lamangcwaba lawa lapha yiwo ihamba phezulu ukuthi nje abathena nxa ihamba phezulu bathi ngizabe nyakhele khona phana ngingasusi.
Abeze-ZPC basithembise kusakhela imizi emitsha ukuthi sisuke laphana basithembisa nje njalo okungama-benefits okuncane ukuthi nxa sesisuka laphana bazasikompaseta ngokunye kwezinto. Imizi abasakhela yona mihle kakhulu. Ngiyathemba liyabona lana izindlu ezikhona zilomehluko kakhulu kulalapho esasihlezi khona. Izindlu sibili ezingathi mina i-high quality, high standard zezindlu siyazithabela kakhulu, siyazijabulela. Siyababonga kakhulu abe-ZPC, siyayibonga kakhulu mbe i-branches zesa kodwa lesakheleyo eyenza ukuthi sihlale lapha siyayibonga kakhulu. Sengathi hayi umsebenzi wabo angazi ukuthi ngingawudescribe ngithini ngoba umsebenzi omuhle kakhulu. Siyawubonga sivile siwudumisa la kuNkulunkulu.
For the Hwange expansion project, because of its geographical footprint, it interacts or it passes through several communities which are led by various chiefs. I think in total it interacts with more than 10 chiefs, kingdoms, I think. The transmission side is more than 5, the power plant side is more than 5. But I must single out Chief Hwange for the immense role that he played on this project. From the time that we carried out the groundbreaking ceremony, there was a traditional ceremony that was done to pave way, to cleanse and ensure that the project was done in a safe manner.
This undertaking project could to a groundbreaking na His Excellency, our President, Vaidi Mnangagwa. Takata zemijimo zokusha kuna sutango. Kwapikwa usukwa ukavuraiwa jing'ombe ukatiwa mijimu inosotiwa mazvose tikazana vanhu vakazana kwa usiku kuti mishingo ingotangisa ikwende zibodo kusi pane maaccident kusi pane mukani asi mishingo yose chapodo pa ibudire nekuti mishingo ichatisa kuti Hwange nasu vanhu vose veZimbabwe tibudire nemishingo ende.
They've also been instrumental in providing the local labor that was key for implementing the project, but we are glad for the role that all the chiefs played in ensuring that this project progressed smoothly and the support they overall gave to the project.
So, to me, the project has been like a family. There's a team that has been helping me, that has been behind me. And I also have engineers that I worked with, technicians that I worked with, they went over and above what was required for them to achieve that.
As I'm speaking now, I don't represent myself as an individual. I have a whole lot of other engineers that I work with. It helps in driving the project when you realize that you have other young engineers looking up to you for solutions, and it motivates. It motivates.
I want to thank my team because obviously I'm representing them here, but I didn't do it by myself. I had a team of technicians, I had a team of engineers that we worked together to make this project a success. The technicians ensure that they did the site monitoring. They've been there for every test. It doesn't matter whether it's in the middle of the night or during the day. They had to work overtime. And the engineers had to ensure that the designs and everything, they gave their engineering support and they gave their expertise. I believe every one of my team gave their all.
This is one thing that inspires me as an engineer, to see something from birth, to see something from concept, to see it coming into fruition, to see it impacting especially people's lives. I know there's now a hospital that has electricity, there's now a child who can read, there's now someone who can cook. That alone gives me so much satisfaction.
Getting the 600 megawatts to the nation, it means I would have contributed significantly to the kids out there that will want to realize, or that who are still dreaming to get somewhere with life. That alone gives me a sense of achievement, and for that I'm happy.
As an engineer, my biggest responsibility is to make the lives of people better. So, coming from a country which had a great energy shortage, and being able to bring in 600 megawatts into the grid is a very, very big achievement. I feel as an engineer I've done my duty, I've done my best.
Which means our industry is getting electricity. That means increased production in our economy. Our nation is one step closer to fulfilling the objectives that have been set out by our government. So I think being part of that is really something else.
I'm happy that through this project and the opportunity that was accorded to me by the organization, I managed to touch the lives of many by making sure that each and every household in Zimbabwe at least gets power. And being the project manager and the project driver, the face of the project, is something that was so immense. And I'm grateful to the organization for bestowing that responsibility to me.